So the point of these last few problems is to change these from log equations to just other expressions with variables. And the nice thing is that they tell you what specifically you're going to use to break things down with. So for example, right here they give you that log base 7 of 2 is A, and log base 7 of 3 is B. Okay, so your goal is going to be to take the log that they give you and maybe split it up using these two somehow. Okay, so first of all, 6 is what? If you multiply 2 and 3 together, that is exactly the same thing as 6, right? And now yesterday, if we see multiplication, how can this be rewritten? Yeah, addition. So this becomes of 2 plus, very good. And now the whole point of doing that is they told you what these are. Log base 7 of 2 is A. Log base 7 of 3 is B. So this is your answer. It's just going to be A plus B. Okay. Let's try this one. What would I do with the 8? So it's 2 times 2 times 2. Okay. So that's one approach. Anybody have a different? Well, we don't know 4, right? Could you write this any other way? 2 to the power of 3. So that would be another option. Okay. Either way is going to work. This one, you see you're adding or multiplying, so you're going to add. So it'll be log base 7 of 2 plus log base 7 of 2 plus log base 7 of 2 using that same multiplication property. And so what do we get? Yeah, A plus A plus A is 3A. Now, if you had done it this way, what can we do with this exponent? Put it in front of the log. And now what is log base 7 of 2? And either way, we get the same answer. Okay? Why don't you guys try this last one? What do we do with the 4? 2 squared, or 2 times 2? Yeah. What about 27? 3 cubed. I know that's what you meant. And so now we're going to use both of those properties for exponents and division, right? This 2 will go in front of the log, base 7 of 2, and then what's the last half? Minus, you meant 7, but yeah, and then 3. Does that make sense? Okay, and again, The reason that we can do that, or that we want to do that rather, is we know what these two are. They're just a and b. So our final answer is 2a minus 3b. Okay? So this is what we would say are easier examples because you're literally using only what they give you, right? You're using the 2 somehow, or you're using the 3 somehow, or both. Okay? This next set of examples here, you're going to see that we don't necessarily only have to work with those numbers. So let's try this first one. 12. Well, I can use a 4 certainly to split it up, right? But does 5 go into 12? So I'm not going to use that. But let's use the 4. How would I rewrite this? 4 times what? Okay. And so now using those properties of addition, we know that this is log base 3 of 4 plus log base 3 of 3. This one they gave to us. What's log base 3 of 4? A. This one they didn't give to us. But there's a reason. You should know what that is. What's log base 3 of 3? Because 3 to the first is 3. Right? Or now that you're starting to see all these other properties, you could also write this as log 3 divided by log 3, which is 1, because it's the same thing over the same thing, right? Lots of ways to kind of reason your way to this answer, okay? All right. Let's try B. How could I split up the 100 there? What is it? 10 times 10? Can we do 5 times 5 times 4?
Yes.
I would say yeah, and that's
Okay. I don't know. I was asking because you know how like that first one you look for one.
but that's actually the ideal scenario where you're only just using the numbers they give you, right? So 5 times 5, that's the same thing as 5 squared. 25 times 4 is 100, right?
So you want to use the smallest number first?
Yes. And ideally the numbers that are given to you. Okay? And so let's write it out. What would this be now if I use the properties we've been studying? Of 5, right? And then plus log base 3 of 4. So now we just plug in what we know. What's our final answer? Does that make sense, you guys?
Yeah.
Where's the 2 down? 2 log base 3.
Because you have 5 squared, so you get 2 5s.
It's right there.
Okay.
It didn't go anywhere. It's still there. Are you wondering how we went from here to here?
No.
Okay, yeah, it's still there. Okay. It's all right with you. I'm going to skip C. Okay, similar. Let's go on to a couple of these. Okay. So for this last set of examples, we want to express y as a function of x. In other words, tell me what y equals is what they want. Okay. Let's pretend like we don't know anything, and we're just going to see what happens. So natural log of y, I really can't do anything with that on the left, right? But what can I do here if I'm adding 2 logs? So what would this be written as? Of what? 6x times c, yeah. Does that make sense so far? Okay. And actually, we're pretty much done at this point, because if on the left we have the natural log of y, and on the right we have the natural log of something else, Is it clear that these need to be equal to each other? So there it is. Y has to equal 6xc.
Technically, don't divide by the natural log.
Well, no,
Those cancel.
you can't divide by natural log because you'd have to divide by the natural log of something. That's actually a really good question that you're asking. So what David's saying is, could you say, let me just rewrite it again. Divide by natural log, right? It looks very tempting to do. Agreed? And then it looks like, oh, cancel, right? And then you get y equals 6xc. It looks visually appealing because it seems to make sense, but let me compare this with something you are very familiar with, okay? Whenever you see a log, you need to have something inside it. Does that make sense? Just like if you see a radical, you'd have to have a radical with a number inside it, right? So dividing by this, I have some space down here, would be like if I had the square root of 5x equals 2, and I ask you how to solve, and you go, well, let's just divide by the square root. You see what I'm trying to say? Cancel the roots. So now we get 5x equals 2 over, well, that doesn't make any sense. You see what I'm saying? Numbers got to be in there. Okay, so back over here.
So y is y equals
Well, because if you're doing the natural log of a number and it equals the natural log of something else, the only way these are equal is if what we're doing the natural log of are equal. Does that make sense? That's the way I'm going to leave it for now because we're actually going to talk about why these are the same. Okay, but for now, that's a good enough explanation, I think. Okay. Let's go ahead and do D. Okay. So we have log base 3, y plus 4. We can't really split that up or do anything with that, right? But over here, we have 9x minus log base 3 of c.
Could you move the log to the other side?
So if I move the log to the other side, that's a great idea. Plus log base 3 of c equals 9x. It looks like we maybe just moved stuff but didn't get anywhere. But now that I have more than one log on one side, what could I do? You can multiply. So this will be log base 3 of y plus 4 times c. Does that make sense? Equals 9x. And this is actually a preview to where we're headed. So over here, we had a log on this side, a log on that side. We just said, oh, well, the two things on the inside got to equal each other. Otherwise, this doesn't make sense, right? Here, I don't really have that luxury. What can we do when I have a log equation, when I'm stuck and I really can't do any more work? Switch it to what? So what would it be? Yeah, exponential is correct.
So 3 to the power of 9x equals 9 plus 4c. Or y plus 4c.
I figured that's what you meant. You guys see where he's getting that from?
Yeah.
Okay. And now, the goal here is to get y alone. So I'm going to distribute the c here. And I know we got variables and letters and all, but you still do exactly what you would do if these were numbers. How do I get y alone? What can I do first? Before we divide or multiply, is there anything I'm going to add or subtract? So 3 to the 9x minus 4c equals y times c. And now what can I do to get y alone? Divide by c. Very good. So 3 to the 9x minus 4c over c is equal to y. Okay? These other ones are similar, but I think just doing those couple is good for now. You guys will have a chance to practice these later on. Okay? Let me stop that.